Welcome to Azure Data Engineering Training Presentation by Navonu Enterprises. 5 things. This video will help you understand. 1. What is data engineering? 2. How data engineering helps a business like McDonald's. 3. Azure Data Engineering Architecture. 4. What you will learn in the Azure Data Engineering Training. 5. Azure certifications AZ900 and DP203. So, what exactly is data engineering? Let's face it, everyone in IT is talking about it. It is discussed in meetings. Interviewers are looking for data engineers more than any other skill in IT. Data engineering blogs are everywhere. Videos are being made. Despite all this, everyone is still confused what the term data engineering actually means. Some think it is data science. Some think of it as data warehousing. And some, data analysis. Now, let's look at a simple definition of data engineering. Data engineering is all about the movement, manipulation, and management of data. Its main purpose is to fuel AI technologies and machine learning models. Now, let's look at the history of data engineering. Data engineering always existed in companies in some form, but it was never an organized process until recent past. With the rise of AI and analytics, companies spent lavishly on data science talent, hoping to reap mega bucks. However, very quickly they realized that most data scientists and machine learning engineers struggled with data extraction, data cleansing, data access, data transformation, and data infrastructure. This is where data engineering comes into play, and data engineers come to the rescue. There is a famous joke amongst data engineers. Data engineers are recovering data scientists. So, why is data engineering suddenly in demand? So let's look at the data in data engineering. Simply put, data is the new gold. So what is data? Data is nothing but an event that is recorded or stored. It can be stored on an external drive, say a floppy disk, computer hard drive, in files such as Notepad, Excel or CSV, a relational database or RDBMS, and even an NoSQL database. Data is in constant creation. Let's look at a few examples and see how it is generated. Data is created when you like this video, make a post on Facebook, or tweet someone. When you purchase something online, make financial transactions, trade stocks, purchase an airline ticket, or swipe your credit card. It is never ending. Every time you generate data, you create a pattern. Companies are interested in knowing these patterns so they can know what is going in your mind. That way they can sell you things you want to buy based on your buying patterns, or entice you with newer products you might not even know you like. It helps companies run targeted promotions based on those buying patterns on holiday events like Black Friday and Cyber Monday. Let's look at the various types of data classification. The biggest challenge AI faces is collecting data from all separate sources and making it useful for analysis and prediction. In an organization, data is stored in various formats and in various data sources. Data can be classified in 3 ways. 1. Unstructured data, also known as raw data. Social media content. IoT data, such as GPS, temperature, sensor readings. Videos and blogs. Images. Audio files. Emails. And chats are all examples of unstructured data. Semi-structured data. Files in JSON, XML, HTML formats. Log files are also considered semi-structured data. 3. Structured data. It is in a tabular format with rows and columns. Some examples of structured data are RDBMS, data warehouse, and CSV files. Now let's see how are cloud and data engineering related. Cloud allows users to access and store data and applications on remote servers rather than on local devices or personal computers. It provides servers, storage, databases, networking, software, analytics, and intelligence over the internet. Cloud provides data engineering with scalability, security, and tools to effectively manage and process vast amounts of data. Now, let's look at the major cloud computing providers: Microsoft Azure, Amazon Web Services, also known as AWS, and Google Cloud Platform, also known as GCP, are the major cloud computing providers with the largest share of the cloud business in IT. Microsoft Azure and data engineering. Microsoft Azure is a public cloud computing platform. It provides a broad range of cloud services, including compute analytics, storage, and networking. Azure is stronger than ever, with over 95% of Fortune 500 companies using Azure. Azure is used for data engineering and provides various data services and frameworks to store and produce cleansed and enhanced data sets for analysis. Now, let's look at a real-life use case as to how Microsoft Azure can help McDonald's grow and streamline its business. The CTO of McDonald's is looking to leverage data engineering to optimize its operations, improve customer service, and make informed business decisions. He directs his business team to implement this. The business team meets with the head of data engineering to put this plan in effect. The data engineering tech team, after several discussions, comes up with a project plan. It wants to collect and analyze data from its drive-thrus, restaurants, mobile apps, social media, and other sources to enhance its overall performance. Step 1. Data collection. McDonald's installs IoT sensors in its restaurants and drive-thru lanes to collect real-time data on customer traffic, order volumes, waiting times, and order accuracy. Data is gathered from mobile app usage, online orders, and customer feedback forms. Data is gathered from customer likes on Facebook pages, tweets, and Instagram posts. McDonald's also collects transactional data, which is entered through POS systems at its 40,000 restaurants. This data is stored in a relational database, also known as RDBMS. Step 2. Data storage and transformation. Data usually comes in two forms: batch data, streaming data. Now, let's look at the Azure Data Engineering architecture to understand the McDonald's use case. Live streaming data coming from the IoT devices in McDonald's drive-thrus is sent to IoT Hub. IoT Hub routes data to Data Lake using built-in routing. The live streaming data from McDonald's online orders and social media is sent to an Azure Event Hub. Azure Databricks ingests raw streaming data from Azure Event Hubs using Spark and is stored in Data Lake. Batch data is a large amount of data that is processed at once, at specific time intervals. Using Azure Data Factory and Azure Databricks, data engineering team build pipelines for batch data. It helps create, schedule, and manage data-driven workflows and automates data movement and data transformation. Batch data coming from databases, CSV or other files is ingested inside the data lake at specific time periods of a day. Now let's look at what a Data Lake Storage Gen 2 is. Azure Data Lake Storage Gen 2 is also known as a data lake. It can store both batch and streaming data. It can store structured, unstructured, and semi-structured data. It stores logs, raw CSVs, Parquet files, images, and other unprocessed data. It is a storage layer where raw data is dumped. This is then processed and analyzed using various Azure services. Now let's look at another important component of Azure Data Engineering: a Delta Lake. Delta Lake is an open-source storage layer designed to run on top of an existing Azure Data Lake. It improves reliability, security, and performance. Delta Lake supports ACID transactions, scalable metadata, unified streaming, and batch data processing. Data inside Azure Data Lake is in raw form and is then restructured to follow the Delta Lake format. Delta Lake stores data in Parquet format, a columnar storage file format optimized for analytics. Delta Lake uses a specific architecture. This architecture used by Delta Lake is also known as a multi-hop architecture. It allows data engineers to build a pipeline that begins with raw data as a single source of truth from which everything flows. It allows batch data and stream data to be combined and unified for feeding the machine learning models. This architecture consists of 3 tables: bronze, silver, and gold, which correspond to different quality levels in the data engineering pipeline. The first table in the multi-hop architecture is called the bronze table, also known as raw data layer. This is the initial landing zone for the raw data ingested into the data lake. Data is stored as is, without any transformation or cleansing. The goal is to capture the full history and have a point-in-time snapshot of data sources. Azure Databricks performs preliminary data processing using Apache Spark on raw data such as A. Filtering out corrupted records, B. Combining data sets, C. Decompressing files, D. Converting data formats from CSV to Parquet for more efficient storage. The second table in the multi-hop architecture is called the silver table, also known as clean data layer. The data is now more structured and refined than the bronze table, but not in its final aggregated or business-ready form. Databricks is used for transformations, like joining data sets, filtering, and adding calculated columns. This data can be used by data science team for model preparation and model training using Databricks MLflow, an integral component of the pipeline. The third table in the multi-hop architecture is called a gold table, also known as aggregated business layer. The gold table contains data that has been further transformed, enriched, and aggregated to serve specific business use cases and reporting needs. Data in this layer is optimized for consumption by BI tools, dashboards, or other end-user applications. So let's see what the gold table data is used for at McDonald's. This data, being highly refined, is typically optimized for query performance. This means fast access and efficient machine learning model training. Gold table data sets can be exported out of the data lake into Azure Synapse. SQL pools in Azure Synapse provide a data warehousing and compute environment. For McDonald's data scientists, the gold table represents a treasure trove. They use it for building and validating machine learning models because the data is consistent, enriched, and ready for model training. Power BI can use this data to generate analytical and historical reports/dashboards. Now let's put all this in context and see how McDonald's benefits from Azure Data Engineering. Because of the data engineering pipelines, McDonald's data science and business teams would be able to 1. Perform predictive analysis, 2. Sentimental analysis, 3. Sales reporting. This all would help McDonald's with 1. Demand forecasting. This predicts the demand for specific menu items, minimizes food wastage, and ensures fresh ingredients are always available. 2. Optimize staffing. This helps forecast busy times for restaurants, allowing staff optimization during peak times and slower periods. 3. New product launches. This helps estimate potential demand, guide production levels, marketing spending, and rollout strategies. 4. Promotional campaigns. This helps analyze past promotional campaigns and current market trends to which promotions might be most successful and drive the most sales in the future. 5. Drive-through and delivery efficiency. This helps estimate the demand for drive-through or delivery services at different times, enabling efficient logistics and operations. 6. Location analysis for new outlets. McDonald's can now estimate the potential success based on factors like location, local demographics, traffic patterns, and proximity to other businesses or attractions. 7. Personalized marketing. Helps predict individual customer preferences and tailor marketing messages, promotions, menu recommendations to individual customers. 8. Supply chain optimization. This predicts the demand for ingredients and supplies to streamline the supply chain, negotiate better prices with suppliers, and reduce costs. 9. Customer feedback and sentiment analysis. This predicts trends in customer feedback. Sentiment analysis on social media anticipates potential issues. 10. Competitive analysis. Anticipates moves by McDonald's competitors, allowing to devise strategies to maintain or grow their market share. Now let's explore what you will learn in this training. 1. Introduction to Data Engineering on Azure. 2. Build data analytics solutions using Azure Synapse serverless SQL pools. 3. Data engineering with Azure Synapse Apache Spark pools. 4. Data warehouses using Azure Synapse Analytics. 5. Transfer and transform data with Azure Synapse Analytics pipelines. 6. Work with hybrid transactional and analytical processing solutions using Azure Synapse Analytics. 7. Implement a data streaming solution with Azure Stream Analytics. 8. Govern data across an enterprise. 9. Data engineering with Azure Databricks. Let's look at the Azure certifications this training will help you obtain. The first certification is Microsoft Certified Azure Fundamentals, also known as AZ900. AZ900 is generally for individuals new to Azure. It validates foundational knowledge of Azure cloud concepts. It will test for cloud concepts, core Azure services, security and privacy in Azure, subscription and support, compliance, trust, and security. The second certification this training will prepare you for is Microsoft Azure Data Engineering Associate Professional Certificate, also known as DP203. This certification demonstrates that the holder has the skills and knowledge needed to work as a data engineer on the Azure platform. This involves understanding various data storage options in Azure, like Azure SQL Database, Azure Blob Storage, Azure Data Lake Storage, and Cosmos DB. It covers the design and implementation of data processing solutions using services like Azure Databricks, Azure Stream Analytics, and Azure Synapse Analytics. If you like the content, please like and subscribe this video. If you have any questions about this presentation or future Azure Data Engineering training, please call us on 732-889-4242. You can also email us on trainings@nirvanaenterprises.com